Hello everyone, you are welcome to this class. So in this class we want to look at mensuration of solids, which is also known as mensuration of 3D shapes. So 3D shapes, as you all know, you have done that before, so there is not much to do on that. But what we have in mind in this video is to look at surface areas and volumes of prisms. So prisms, so we look at the meaning of prisms, look at types of prisms that we have, and we look at surface areas of volumes, surface areas and volumes, sorry for that, surface areas and volumes and the volumes of prisms that we have. So that is what we have for us in this video. So you have to be patient because in this video we'll be talking about formulas here, and I'm not going to just write out the formula for you. That's one thing I usually do. I'll show you how the formulas are being derived. So we're going to derive the formula by ourselves, so that if you want to record the formulas, it'll be easier for you to recall. So that is one of the purpose of this class. So we are not only learning, giving you the formula, you are learning how to get the formula yourself. So that when you get stuck, you can go back to the basics and what bring out the formula. So I hope that is very clear. So we go to what are prisms, what is the meaning of prism. So when we talk about prism is a three-dimensional shape. A prism is a three-dimensional shape uh, that have two similar shapes facing each other. That is, there are two similar faces. It has two similar faces. So prism has how many faces? Two similar faces facing each other. Let me adjust this, okay? Okay, I think it's better now. Right. Sorry for that. So they have uh, they have two similar shapes facing each other. Now, if you look at the shape we have here, this shape here, what you're going to see is that the shape we have here, this rectangle here, this triangle rather, the same thing with this triangle. All right. So a prism is a shape that will have the same shape at the top and the same shape at the bottom. So the bottom of this shape here is this triangle, and the top is same thing as this what triangle. So and the distance between the similar shapes we have there, which is this place, which is this line, is the height of the prism. So the way this prism is now is not they are not placing it uh, properly. So this is the base, and this is the height. So the difference between the two similar faces is called the height. Then the identical shapes are the base. So this is the base and this is the top. The top and the base are the same. I hope I'm making sense. So that is what prism is. And this type of prism, so a prism, the name of prism will be determined from the type of base it has, the shape of the base. So for this one, the base of this prism here is triangle. So therefore, this we will call triangular prism. It's going to be called what? Triangular prism. But when it comes to the one with a rectangle, that one has another name. We can call it rectangular prism as well, and we can call it a cuboid. We are still going to look at types now. Then we also have, if the shape is has 5 sides, so that will be pentagonal prism. If it has 6 sides, that will be hexagonal prism. If it has trapezium as the base, that is, you have the trapezium at the bottom and also have trapezium at the top. So it's going to be a trapezoid prism. So we're going to look at their areas and their volumes. So just keep calm and let's see how this one goes. So we move to the next one. So the next one here, the types of prism that we have that I've explained earlier on. So you can see this is triangular prism. So this one is well placed now. So if you look at the top here, it's triangle, And if you look at the bottom, is also what? Triangle. And the difference between the top and the bottom is the height, as you can see there. So that is triangular prism. So difference between the top and the bottom is known as what? Is known as the height. Then we also have, beside it, we have square prism. Square prism is also known as cube. It's also known as cube because all the sides are the same. This equals to this, 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 and this. All of them are the same. So that is cube. This is what cube. Then we have pentagonal prism. Pentagonal prism from the word pentagon. From the word pentagon. It has 5 sides as a base. So the base is pentagonal shape, plane shape. So therefore, that prism is pentagonal prism. So that's the same thing. You can see the distance between the top and the bottom is what height. Then rectangular prism, which is also known as cuboid. Cuboid. So you can see the top is in form of rectangle, while the base will also be in form of what? Rectangle. So that is why it's called what? Rectangular prism, and it's also referred to as cuboid. Then we have hexagonal prism. That means it has 6 sides at the base and 6 sides are shown. 6-sided shape at the base and 6-sided shape at the bottom as well. So we also have octagonal prism. Octagonal, that is, it has 8-sided as a base and also as 8-sided as a what? Bottom. The same octagon. Octagon. So that is what is called what? Octagonal prism. Then we have trapezoidal prism. So what you can see here guys is this is trapezium here. This is trapezium. And what you have at the bottom as well is also what? Trapezium. So that is, and the difference between the trapezoid is what? Is the height. I hope this is very clear. So these are, we have, it's plenty, but we cannot exhaust everything. So it depends on what you are given. We are going to show, I'm going to show you in this video how you are going to get their areas, surface areas. Then we also have cylinder as well too. Cylinder too is also part of it. It's also part of the cylinder. So that one is a circular prism because the bottom and the top is in form of circle. So this is a cylinder. So it's also a prism. All right. So we also this is the height. This is the base. I hope I'm making sense. All right. So we now move to surface areas and volumes. How do we calculate their surface area and volumes? It's so simple. So one thing you just know, you're going to be recalling some previous formulas we have learned. We'll be recalling them and be applying them. So we're not going to look at everything in this video. So, but I will show you the basis for some of them. Then you now go and determine the rest for yourself. I hope that is very clear. So move to the next one, and that is a surface area. So we start with a triangular prism. So we want to get the surface area and at the same time the what? The volume. So to get the surface area, so what you're going to notice is this. This is the base. This is one face. With the first thing, let's look at how many faces do we have here. This is 1, this is 2, this is 3, and this one here is 4. We have 4 faces. Now if you look at this, 3 and 4 are the same. No, sorry. Then we have another one, 5 at the bottom here. Are you with me? We have 5 faces. So let me do that again. Let's do that again. Let's do that again. So this is the first one, and this is the second one. So the one at the bottom that is sitting on the floor is the third one. Then the one beside here is the fourth one, and the one outside here, let me shade it so that you can see this one here, this one, okay, so this one here, all right, so is the fifth one. This is the fifth one. All right, so which means it has 5 faces. Now The issue now is that for 1 and 2, 1, let me write here, 1 and 2 are the same. Then 4 and 5 are also the same. So if you open it, if I want to open it now, this is what I'm going to have if I want to open it. I'm going to have this, something like this. I'm going to have this. Then I have a rectangle here. Have another rectangle here, triangle here. So then we are going to have a rectangle here. We're going to have another rectangle here. All right. So this is 1, this is 2, all right. This is 3, this is 4, and this is 5. I hope I'm making sense. All right. So that means that, so 4 and 5 are the same, 1 and 2 are the same. It's only 3. So then 3, 2. If you look at 3, 3, 4, 5 are the same. They are both rectangles. So what we're going to do, find the area of this, which is length times breadth. Area of this, length times breadth. Area of this, length times breadth. Then area of triangle here, which is what? Half base times height. Here also is half base times height, depending on the type of triangle given there, that will determine how that one will look like. I hope I'm making. So if I have to, if they not ask you to find the surface area of this prism here, so you know what to do. So find the area of the first rectangle. So for example, if this is given, this is the length, this will be the breadth. All right. Then for this one, to this is same thing as the length. It's the same thing as the length here. And the length is also the same thing as the length here. I hope I'm making sense. This breadth here is the same thing as this breadth here. This one, this line here, this is the same thing as breadth, same thing as the breadth here. I hope I'm making sense. So that's how you do it. So when you see example, that it will be easier for us to get. So for us to now write this out, so it will be 3 into length times breadth, because we have 3 here. Then plus 2 into half base times height. It depends. It depends. If the size here is here, and same. So that's how, why this one will be this. Then this one is constant. So whichever one you are given, so we have three types of calculating area of triangle. We have Hero's formula, that whereby you have square roots s into s minus a into s minus b into s minus c, where s is a plus b plus c. When you are given scaling triangle, that's what you do. But if you are given a right angle triangle, you can apply this. Then you have the one of sine ab sine theta. So when you are given an angle and what, 2 sides, you can as well apply that one for area of triangle. But that's not for the purpose of this class. How this one is clear to you now. So the next one is now to look at the volume. Volume of any prism is the same throughout. Volume of any prism, it has one formula. And the volume of any prism, I don't want to know what the prism is. Volume of any prism, volume of a prism is what? Base area times what? Times height. So volume of this one will then be, what's the base area? Half times base times height. Then times the height of the prism, which is the h. That's all. So that is the height. That is the volume of triangular prism that we have here. I hope this is clear. Then move to the next one. This is cylinder. All right. This is cylinder. So this is cylinder. So this is a cylinder here. So we want to calculate the surface area of this cylinder. So now there's video that I did a video on this one. You can as well check the channel to find out and see how the area of total surface area of cylinder has been derived. But for the purpose of that, I'll just give you. So volume area of this cylinder, it is divided into about 3 curved surface area. Sorry, we have curved. So this is the curved part. So curved surface area, which is 2 pi r h. and the area of the circular base, it has two circular base, right? Two circles here. So that's this will be what pi r squared. This is also what pi r squared. So if they ask you to find the total surface area of a cylinder, that's going to be this one, they adjust to, that will be 2 pi r squared plus 2 pi r h. So if the two circular faces are covered, but if one is opened, so therefore these two will not be there. It will be pi r squared plus 2 pi r h. But the question asks you find the curved surface area of a cylinder. This is what you are going to do. Use. I hope I'm making sense. Please take note of this. It's very important. So then for the volume, so since it's the same thing as the prism, so volume of this one will then be base area, which is pi r squared, then times the height, which is h. So therefore, the volume of a cylinder is of pi r squared, what, h. You can see how it is being derived? Right. So that is that for cylinder. Let's now go to cuboid. For cuboid, this is a cuboid. For cuboid here, we want to calculate the surface area of this cuboid now. So one thing you're going to notice here is that this is 1, this is 2. They are the same thing. The one at the top here, 3. The one at the bottom here, 4. The one beside here, 5. The one beside here, 6. So we have 6. It has 6 faces. All right. So 1 and 2 are the same. So you find the area of this one. So if you look at this, this is the length, this is the breadth, and this is the height. So look at what I'm going to do. Let me erase the numbers. So we'll be picking them one by one. Length, the breadth, and the height. Now I will shade these parts. Let me shade these parts and this part first. Alright, I hope that is clear. Now, for this part, what we have here is what? B times H. The same thing will be this one. Sorry for that. B times H. B, this is the breadth and the height. That's the area of this one. B times H. Alright? Then the same thing with this one. B times what? H. So that is that for that one. So let's shade this one. This one and the whole of this one facing. So that is length and H. So this will be what? Length times H. This one as well will be length times what? H. Then to remain the bottom is length and breadth. Length times breadth. And the top will also be what? Length times breadth. So which means you're going to have 2 into bracket length times breadth plus 2 into bracket B times H, then 2 plus 2 into bracket what? B times H, then length times H. That is why in some textbooks you see is the breadth is known as width, right? You see 2 into L times LW plus 2 into bracket WH plus 2 into bracket LH. So that is that. That is the formula for calculating surface area, total surface area of a cuboid. I hope that is very clear. So for the volume, it will be the base area. What is the base now? Length times breadth. Then the height, the difference between the two heights is what? 8. That is the reason why it is what? Length times breadth times height. That's volume for calculating total surface area of a cuboid. I hope this is very clear. So we'll move to the next one, and that is going to be cube. So that's going to be cube. So they're almost the same thing. For cube, so what we have in cube is this. So the cube, the same thing. If you shape this, the top part and the bottom part. So since all the sides in cube are the same, this is length, is equal to length is equal to length. All right. So everything, since this one has 6 sides as well, so this is going to be 6 times L squared. 6 times what? L squared. So 6 faces. So each face, the area of each face is length times length. That is length squared. So total surface area of a cube is what? 6L squared. I hope I'm making sense. So that is that on that one. All right. That is that on that one. So we'll move to the next one. Okay. So the next one here is a trapezoid. So trapezoid, if you look at this one, this is in form of trapezium. It's in form of trapezium. So what that means is that we have trapezium. You can see the side that is shaded here. So let me shade the opposite side, which is this one. You can see that the same. So that is trapezium. So this difference between the two is the height. This is the height. All right. So which means we're going to find area of the trapezium, which is we are going to have one here, another one here. That is 2. We find this side here and this side are the same from what I can see here. Then the bottom and the top here are different here. Exactly. So you find their area. So for you to do that, so area of trapezium is half into a plus b bracket h. So which means we're going to multiply by 2. So these two cancel. That will be a plus b bracket h. That is, we have find the two sides plus the area of this shape and this shape. That will be 2 into length times base times height. That is the height of the h times L. Then plus the other one, which is area of triangle there, of rectangle, that is length times breadth. We calculate that, plus the bottom as well is in form of rectangle as well. So that is length times what? Breadth. But they are not the same. This and this are not the same. That is it. Then for the volume, the volume will still be the same thing. Area of the trapezium, which is the base, a plus b brackets h. So a plus b brackets h, then times the height between the two of them. So this height and this are not the same thing. So the height, this small height is the height of this trapezium here, which is this one. While this one is the height of the prism. So that is that on this. So let's quickly look at some examples. So let's look at some examples before we move on. So let's look at this example 1. Calculate the surface area and volume of the shape below. So if you look at the shape we have there, this is a cuboid, right? This is cuboid. So how do we calculate the total surface area? The surface area. So let's label it. This is the height. The height is 15 centimeters. The length is 20 centimeters. And the breadth is 0.3 centimeters. All that is clear. Okay. So surface area now. Area will then be, so don't forget, 2 into length times breadth plus 2 into length times height plus 2 into base times height. I'll show you now. This is length, this is breadth. 2. We have taken this one. This is the length, this is the breadth. Then for the second one, length and height. That's for this one. Then base and height. That's for this one. So that's all. So I hope that is very clear. So we can then have 2 into length, which is 20, the base, which is 0.3, plus 2 into length, 20, times the height, 15, plus 2 into base, 0.3, times the height, which is 15. So we're now going to calculate that and add them together. So let's look at this. To be faster, let's make use of this calculator here. So 20 times 0.3, that gives 6. So that is going to be 2 times 6 plus then 20 times 15, that is going to be 200, 300, that's 2 times 300 plus 2, then 0.3 times 15, that is 4.5 times 4.5. So this will give us 2, that is 12 plus 600 plus 9. Alright, so we add everything together. So that's going to be 600 and there was 11. So centimeter squared. So that is that. That's the answer to this. I hope this is very clear. Alright. So move to, oh, this is not showing properly. Okay. Six 11. 611. I hope this is very clear now. All right. So move to the next one. We have calculated the area. It remains the volume. So for the volume, so let's erase this. For the volume, so that one is very straightforward. For the volume, uh, for the volume now. For the volume, so volume of cuboid here is equals to base times length times breadth times height. All right. So what is the length? 20 times 0.3 times 15. So this is going to give us 20 times 0.3 times 15. So that gives us 90 cubic centimeters. It's going to be cube. All right, go to example 2. Example 2, this is a cylinder, right? So we want to find the surface area. So surface area of this one is straightforward. So, and that is, we're going to have, I've given you the formula, that is 2 pi r squared plus 2 pi rh. So that means 2, so pi is 22 over 7. 22 over 7, is it showing? See if I know. It's not sure. Okay. Let's hold on. Okay. Okay, let's do it somewhere here. So we have area is 2 pi r squared plus 2 pi rh. So here the pi is equal to 22 over 7. The radius is 8 and the height is 15. I hope this is clear. Okay, good. So we can then use this to find the area. All right. So that's going to be 2 times 22 over 7 times radius, that will be 8 squared plus 2 times 22 over 7 times radius, which is 8, times height, which is 15. So we can just multiply the numerators and find their LCM. So that's going to give us 44 times 64. That gives us 2,816. 2,816 over 7 plus 44 times 8 times 15. That is 5,280 over 7. So when we add these two of them together plus 2,816, 2,816. So we have 8,096 divided by 7. So that gives us divided by 7. So this gives us 1,156.6 centimeters square. So that is the surface area of this cylinder. Then for its volume, we're going to have, so calculate its volume here. So its volume is going to give us, so since the uh, the radius the radius the radius is equal to 8, the height is equal to 15. So volume of a cylinder is what? 2 pi r square h. So that is 22 over 7 times the radius, which is 8 squared, times a, which is 15. So we can as well do that. That is 22 times 64 times 15. So that gives us 21,120 divided by 7. So this gives us 3,017 centimeters cube. So that is this video. So this is where we're going to stop because of the time. Time is fast spent. I don't want the video to be longer than this. So we stopped here for today. So in our next video, we look at other aspects of the mensuration of a solid, and that is going to be we've looked at prism today. We're going to look at pyramid. We're going to look at pyramid in the next video. So I hope you find this video useful and helpful. So if you are new to this channel, don't forget pyramid. We're going to look at pyramid in the next video. So I hope you find this video useful and helpful. So if you are new to this channel, don't forget to subscribe and make sure you turn on the notification bell so for notification of videos. So this is what we're going to stop. We're going to meet in our next video. Bye for now.